Hello to everyone. This presentation is about the work entitled Experimental and Numerical Investigation of Residual Stresses in Dissimilar butt-weld joint made of cast iron and mild steel. The study of welded joint between dissimilar materials represents an extremely interesting frontier in structural design. The possibility of combining different materials offers enormous potential, as it allows materials with strategic properties to be incorporated at critical points. On the other hand, however, producing high-quality joints without compromising the properties of the materials presents a difficult metallurgical challenge. The use of cast iron is not a casual choice because, as is well known, these materials present difficulties in terms of defects and the formation of extremely hard and brittle microstructure when welded. The experimental joint was first subjected to radiographic analysis, then to micrographic analysis, and finally to hardness testing, revealing the absence of defects into the joint and hardness levels that were not excessively high in heat-affected zone. A finite element model was created to evaluate residual stresses. The welding process was modeled using the burst and death technique, and the thermo-mechanical analysis was carried out in a decoupled manner, first performing the thermal analysis to obtain the temperature distribution, and then the mechanical one to evaluate residual stresses and deformation. The numerical model was then validated indirectly using a method already commonly employed in the literature by comparing the temperature distribution, the shape of the thermally affected zone, and the deformation measured numerically and experimentally. In this way, it was possible to establish a good correlation between the numerical and experimental results. In conclusion, this study demonstrates that, using a validated numerical model, it is possible to obtain an accurate assessment of residual stresses and deformation even for hybrid cast iron steel joints, providing fundamental results for structural integrity of hybrid cast iron steel components. In conclusion, we would like to thank you for your interest and to point out that this research was made possible thanks to the following public funding.